Good evening, good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
What was the last thing we dealt with in the previous class?
So I think today we have to begin with EM waves.
The three block system anyway.
Okay. Vernier caliper screw gauge is over.
Yes, sir.
Ah.
Yes.
Okay.
Okay. EM waves is a tricky situation here in fact.
Sir,
हाँ.
are you going to take any doubt lecture?
डाउट लेक्चर आप लोग बोलो HCV का डाउट्स का रिकॉर्डिंग भेजा है मैंने आपको, राइट? बुकलेट का अगर आप लोगों ने किया है तो आज शाम को ले लूंगा, इफ नॉट मंडे इवनिंग लूंगा. आप लोग जब करेंगे तब बता दो, ले लूंगा.
Today 4 o'clock to 6 o'clock we have a lecture.
What lecture?
Chemistry lecture we are having today. 4 o'clock to 6 o'clock.
Okay. I am perfectly okay either way. All you have to do is you people once your booklet HCV का भेजा है मैंने recording. Other than the problems discussed there, if you have got doubts, kindly let me know. Secondly, booklet अगर हो गया तो keep me informed. I'll take up the doubts. सब जब बोलेंगे तब ले. ACP doubts groups में आप post करेंगे तो भी चलेगा. Sir, we are done with booklet. Doubts, please. I'll take it. Right.
Okay, sir.
And to facilitate your crash course, what they're doing is they'll be starting with electrodynamics so that you will get time for completion of this EMI. Crash course will, one of the student typed, can you take the doubts today? I am okay with it, but it all depends on how many of you have done. Booklet का discussion आज ले ले शाम को 7 बजे.
Yes, sir.
Sir, but
Yes, sir,
exercise
please.
1-2, sir.
Okay.
So otherwise you take till 4, like whoever like has.
So you can take till
you can
3.
see the rec later.
Can you start with 4?
Oh yes, sir. Actually 4 has doubts.
Some students 1, 2, some students 4 नहीं होगा.
Sir, can you please wait 2-3 more days, sir? पूरा attempt ही नहीं हो पाया है अभी.
So Monday or Tuesday, keep me informed. Leave a message in the group.
Okay, sir.
Right. And Monday, many are typing Monday. I'm okay with it. Monday morning, leave a message in the group. Remind me, शाम को 7 बजे रख के खत्म कर दी.
So this will be your last lecture.
Listen. This is important. Your crash course में 24th, 25th part test. I think initially we planned for kinematics, but for you people to get time to complete EMI and magnetism thoroughly, we'll be starting with EMI and magnetism, so that for you in go it will serve your purpose. Your problem will be solved. Right?
Sir, crash course is starting from when?
Next coming Saturday, Sunday.
Okay, sir.
Now, EM waves का ये चैप्टर बड़ा अजीब चैप्टर है. EM waves में.
Sir.
हाँ.
Sir, so in this part test there is no kinetics. It is electrodynamics, no?
That change is being made. Electrodynamics will be from electrostatics to EMI, so that you are getting time to complete EMI and magnetism.
Okay. So in this part test only things will change, right? In this part test, EM or electromagnetism.
Right.
Okay, sir.
So the portion is changing
for the crash course part test, the portion will change. Right? Now, listen. There's a small humming sound from my computer. Are you people able to hear that sound? Is that disturbing you?
No, sir.
No, sir. No, sir.
Okay, fine. Now, all of this is Maxwell's theory. Maxwell's electromagnetic theory. Maxwell's equations में the first equation is Gauss law. Integral E dot ds is equal to q by epsilon naught. First equation, which will be universally right, can be applied always. Second equation is Gauss law for magnetism. B dot ds will be 0. Why? Magnetic monopoles don't exist. Since magnetic monopoles don't exist. Please listen to this very carefully. The third law was Ampere's law. Integral B dot dl is equal to mu naught I. This will go for a change now. This will go for a change. This law is not complete. Maxwell made the correction. Faraday's law, closed integral E dot dl is equal to minus of d pi by dt, was again complete. Our problem was with this particular Ampere's law. What is the problem that Maxwell faced with Ampere's law? I'll explain. And what was the correction he has given will be explained. Take it down.
So just one small doubt for the part test, sir. So for part test in main syllabus, if this electrodynamics is coming, then will electric communication systems be included for mains and semiconductors?
What systems?
Then communication systems and
No. Communication systems. Is it covered by you?
say it is covered and semiconductors also is covered. So will it come in for mains? Part test?
Communication is not a part of electrodynamics. Semiconductors and communication is not a part of electrodynamics.
Okay, sir.
If they are keeping that, they will write that separately in the syllabus.
Okay, sir.
One second.
Done, sir.
Can I rub the board?
Yes.
1 minute, sir.
So 1 moment, sir.
Yes, sir, you can do it now.
So 1 moment, 1 moment. Done, sir. Thank you.
1 second. There is one important thing I have to show you people. For you to understand the correction in Ampere's law. Listen to this carefully.
Flux, you must always specify your surface. A flux can only go through a surface. So this is my surface now for simplicity. And there is a magnetic field coming out of the blackboard at me, and it is growing. It is increasing circuits. And so you define the loop first. Then you define the direction in which you want to march around that circuit. You attach an open surface to that closed loop. And you can determine on that entire surface the integral of B dot dA. Everywhere on that surface, locally you know the dA, locally you know the B, you do the integration and you get your magnetic flux. And then if you know the time change of that magnetic flux, then you know the EMF. If you go around in this conducting circuit, and you measure everywhere the electric field, then the integral of E dot dl, if you go around the loop, would give you the same answer. And that connects the two. The magnetic flux change is connected with the integral of E dot dl when you go around. You have to take that minus sign into account. How come it doesn't matter whether you choose a flat surface or whether you choose a bag? Well, think of magnetic field lines as a flow of water or spaghetti, if you like that, or a flow of air. It is clear that if there is some kind of a flow of air through this opening, then it's got to come out somewhere, so it always comes out of this surface. And therefore,
please observe the plastic bag that he is holding. It has a rim. Do you people observe that?
Yes, sir.
The rim is your ampere and circulation. The rim is your ampere and circulation. Now, why did you show this to us at this particular stage? Because the Ampere's law that we studied, we did in detail tell you through which surface should the current be going. What did you tell me in the Ampere's law? You told me if this is the ampere and circulation, current is passing through it. If this is the current, closed integral B dot dl is mu naught I. You didn't question and we didn't clarify. Is that surface in the plane of this particular loop, which you assumed by default? You assumed the surface through which current is passing to be in the plane of that loop. You assumed that the plane through which the current is passing is in the plane of that particular loop. Need not be, it can be a plastic bag. The plastic bag which he showed to you. You mean to say integral B dot dl to the rim. Integral B dot dl through the rim is mu naught I can be the current passing through this particular surface. Yes. Ampere didn't put a restriction that the surface should be in the plane of the ampere and circulation. ऐसा थोड़ी बोला हुआ है. The plane through which current is passing should be in the plane of the ampere and circulation. Ille, Ampere did not say such a thing. The plastic bag which Walter Levin was showing could be the surface which should be subtending this particular ring. This point, is it clear to all?
Yes,
So
sir.
I'm a little bit confused.
The surface through which current is passing, what were you considering?
So the plane of the loop, like the current passes through the loop.
Need not be the plane of the loop. Ampere never put a restriction that this should be in the plane of this loop. This is the surface through which current is passing. Ille, need not be. It can be the plastic bag which Walter Levin showed.
So the ampere and circulation should always subtend that circle and the current should pass through.
The surface should subtend this ampere and circulation. This is ampere and circulation. B dot dl is through this.
Okay, sir.
The rim that he is holding.
Okay, sir. Thank you, sir.
Sir, but how current can pass through plastic?
Switch off your mind. It is not passing through plastic. It is showing a surface. That's it. That has got nothing to do with this. Now listen. Where is the trouble that we will have? This is a capacitor plate. This is a capacitor plate. There is current flowing in this. Now, assuming an ampere capacitor ke beech, there will be a dielectric, there will be no current flowing. Do you agree with that?
Yes.
Capacitor ke beech, there will be no current flowing. This will be an insulator, dielectric. Now, assuming an ampere and circulation is your job. You can do it, right? Assuming an ampere and circulation, I have assumed an ampere and circulation like this. Closed integral B dot dl is equal to mu naught I. According to your assumption, I is the current passing through the surface in the plane of the loop. I is the current passing through the surface in the plane of the loop. This is what we assume. But Ampere did not insist that the surface should be in the plane of the Amperean circulation. The surface should be subtended by this. It could be this as well, like an earthen pot with the rim. Rim is the Amperean circulation and this is the surface. Could be as well. Or another way of assuming Amperean circulation is like this. This is the current carrying wire. These are the two circular plates. And then current is passing this way. You assumed an Amperean circulation like this. The surface could be like this. Now, if I assume the surface in the plane of this particular loop, then I will get closed integral B dot dl is mu naught I. If I assume the surface in the plane of this loop, closed integral B dot dl along this is mu naught I. I is the current passing through this particular circulation. Same applies here. But if I take this surface, what is the current passing through this surface?
0.
0. What is the current passing through this surface?
0.
0. So if I take this surface, closed integral B dot dl along this will be 0. If I take this surface, closed integral B dot dl along this circular loop will be 0. Now this is contradicting. This is the rim, Amperean circulation. This is the rim, Amperean circulation. Till now, if you were taking a rim, till now, if you were taking an Amperean circulation, till now, if you were taking an Amperean circulation, you are assuming current passing through this only. Little did we know that there can be a plastic cover or a surface through this particular ring, which he showed. So current is not passing through this, but it is passing through this. That doesn't happen. You see a capacitor. If I am taking this particular surface, how much current is passing through this surface? 0. So integral B dot dl along this, for this surface I am getting 0. For this surface I am getting mu naught I, which is a contradiction. Ampere's law tells us we should get the same. Firstly, did you people understand this contradiction?
Yes.
Sir.
So, sir, just because there is no current, the second Amperean surface you have taken, so B dot dl is 0, which is contradicting the first one.
1 second, just wait. Personal picture करना पड़ेगा. Okay. Now, yeah, what were we saying? Somebody was asking some doubt. Say that again.
So, sir, just because there's no current in the second Amperean surface we have taken as B dot.
Surface. Surface subtending the Amperean circulation. Surface subtending the Amperean circulation. Key catch is like this. This is an Amperean circulation. Current is passing through this particular surface or through this particular surface. This is the current carrying wire. Or through this surface or through this surface. Through any of these surfaces, what is the current passing?
I.
Mu naught I. So integral B dot dl along this B dot dl is mu naught I. Agreed?
Yes, sir.
Oh, it may be this surface, it may be this surface, it may be this surface. Net current passing through that will be I. So integral B dot dl along this Amperean circulation will be mu naught I. So this is what Ampere said. Now you applied that for a capacitor and you are in trouble. Through this surface, current passing is I. If I take another surface like this, current passing is I don't have a problem. I take another surface like this, current passing through that is I take another surface like this, current passing through that is I. But if I take this surface, I am not getting current passing is I. For any of the surface I should get I, then it is integral B dot dl along this is mu naught.
Okay, sir.
You understood the controversy now?
Yes, sir.
Now the actual derivation is beyond your scope. Why is this topic not there in your JE advanced and there only for JE mains? No, this is the reason. They'll give you the backward calculation. But NCERT did a wonderful job in giving you the backward calculation. Undoubtedly. Now, they said, till now we are under the belief that current carrying wire produces a magnetic field. This was our bias, our problem. Current carrying wire alone produces a magnetic field, which is wrong. Which is wrong. Undoubtedly, current carrying wire produces a magnetic field, but only current carrying wire can produce a magnetic field is a myth. Then what else will produce a magnetic field? Don't tell me moving charge. Moving charge is current carrying wire. Nature loves symmetry. You heard of this statement?
Yes,
Yes.
sir.
Time
It
varying
was by
magnetic
Bohr.
field produced an electric field. Yes or no? Time varying magnetic field produced an electric field. Yes or no?
Yes, sir.
So time varying electric field also should produce a magnetic field.
Yes, sir.
Yes, sir.
Because of it. So what did nature say? Nature said if time varying magnetic field produces an electric field, time varying electric field also produces a magnetic field. Yeah, how will that help you? In between the capacitor plates, when current is flowing, the charge is increasing. Do you agree with that?
Yes, sir.
This charge is increasing means electric field is increasing. Here in this area, your positive charge is increasing because there is current flowing in the wire. So that means
Yes.
electric field is increasing. Electric field is increasing, so time varying electric field will produce a magnetic field. Right? So Maxwell proposed that if time varying magnetic field produces an electric field, time varying electric field also will produce a magnetic field. Right? So then the $1,000,000 question comes, how much? How do you calculate that and make the corrections here? I'll explain that. First of all, take it down.
Sir, Maxwell had proved this, or was that a hypothesis?
No, he proved that.
Okay.
Though we will not give you the proof now, we give you an indirect means of assessing how much is that value.
Okay, sir.
Center of the board.
Yes, sir.
Now,
Yes, sir.
somebody is asking why is B dot DL 0 for this? Whole of what I have explained till now has gone a waste. There is no current passing through that. अब क्या बोलूं मैं? Capacitor के बीच why is there current flowing? Now, first of all, how do I make a guess as to what is the correction in Ampere's law? NCERT proposed a reverse calculation. What is the reverse calculation? This is a capacitor plate. This is a capacitor plate. This is the electric field. What is the electric flux? E dot A. What is the electric flux? E dot A. Right? Now, what is the field here? Q by A epsilon naught into A. Field in between the capacitor plates is how much? Sigma by epsilon naught.
Yes, sir.
Sigma is Q by A. Q by epsilon naught is the flux. Right? Q will be equal to epsilon naught phi. Q will be equal to epsilon naught phi. You are under the impression always that current carrying wire produces a magnetic field. So how much current do you think this will give me? dq by dt will be the current. Epsilon naught d phi by dt. This is equal. This is current equivalent. But actually the effect is because of varying electric flux. You don't have current in between the capacitor plates. In between the capacitor plates, you have got a dielectric insulator. There is no current passing through it. Do you agree with that?
Yes, sir.
So you are assuming this amount of current to produce a magnetic field. Its equivalent will be epsilon naught d phi by dt. This will produce the same magnetic field. So then Ampere's law went for a correction. B dot dl is equal to mu naught I plus epsilon naught d phi by dt. This is the correct Ampere's law. Either current or varying electric flux or both will produce a magnetic. Either current or varying electric flux or both together will produce a magnetic field. Till now we were taking only current to produce a magnetic field. Time varying electric field will also produce a magnetic field. This is referred to as displacement current. Displacement current. Why again the word current? Is it really current? It's not, but it is your bias that only current produces a magnetic field. So they kept the word current along with it. But the fact being, it is time varying electric flux which produces this particular magnetic field. Can you confirm to me now that your Ampere's law will be valid for a capacitor? Update lo aap. What did you tell me? You take an Ampere in circulation, whether you take this surface, whether you take this surface, whether you take this surface, the current passing through it will be I through this wire. You take this surface, you take this surface, you take this surface, you take this surface. Any surface you take, you should get closed integral B dot dl is mu naught I. Am I right? Now for a capacitor, show to me that you will get the same. Consider this. This is the surface which you had a problem with, right? Now closed integral B dot dl. If I take this surface in the plane of the Ampere circulation, I will get mu naught I. Yes or no? For this surface, I'll get closed integral B dot dl is mu naught I. Yes or no? Please speak.
Yes, sir.
Yes, sir.
Now, if I take this surface, your problem was closed integral B dot dl there is no current passing through this particular surface. That was your problem. Am I right?
Yes.
Mu naught epsilon naught d phi by dt. Epsilon naught d phi by dt is dq by dt. dq by dt. This will be mu naught I. I'm getting back my original answer. Whether I take this surface, whether I take this surface, any of the surfaces. Here it is because of current. Here it is because of the time varying magnetic field. Epsilon naught d phi by dt. Current is 0. So I put current 0 and I took epsilon naught d phi by dt. Epsilon naught d phi by dt is dq by dt, which will be equal to mu naught I. Now whether I take this surface, this surface, this surface or this surface, B dot dl along the rim, I will get the same value. So the correction given by Maxwell solves our problem, isn't it? 1 second, I'll be back in a second. I'll just keep you people on a mute. No, Ampere gave the general law. He never put up a restriction that the surface should be in the plane of the circulation. The restriction was not put by Ampere.
Done, sir.
So now we know the correction in Ampere's law is integral B dot dl is mu naught I plus epsilon naught d phi by dt. We have been confining ourselves to a fact that only current produces magnetic field, time varying electric field as well produces a magnetic field. Now before we proceed, let us learn how much. This is a capacitor plate. This is of radius A. This is a capacitor plate. This is of radius A. I am interested to know what will be the magnetic field here at a distance of R. Magnetic field here at a distance of R. I assumed an ampere in circulation. closed integral P dot dl is mu naught. Do I have current flowing through the capacitor plates? In between the capacitor plates, do I have current?
No.
So here magnetic field will be because of epsilon naught d phi by dt. Agree?
Yes, sir.
Yes, sir.
This will be mu naught epsilon naught. What area of this is intercepted by the magnetic field? No, electric field. This is time varying electric flux. So d by dt of pi r square into the electric field. Till here, is it okay with all?
Yes, sir.
B into 2 pi r into cos 0 is equal to mu naught epsilon naught pi r square dE by dt. Pi and pi, r and r will go. B is mu naught epsilon naught by 2, mu naught epsilon naught r by 2 into dE by dt. The value is of specific importance, right? You are expected to remember. You will see a very strange consequence of this. Now, can you find out the magnetic field outside the capacitor plates? Yes, there will, just as this is a current carrying wire and you have magnetic lines of force outside the wire, outside the capacitor also you will have magnetic field. Magnetic field in between the capacitor plates. In between the capacitor plates. Outside, I will calculate. First to take this down. In the planner that you receive, for once I'm clarifying this, all of you in between the class, stop disturbing me. For once I'm clarifying this. In the planner that you people receive, in that part test in which you had got electrodynamics, and along with electrodynamics, whatever you had in that will be the starting of the parts. Electrodynamics से के स्लॉट में जो जो टॉपिक स्पेसिफाई हुआ those topics से start करेंगे. Your part test में first was kinematics up to mechanics, right? That sequence has been reversed, meaning everything will be the same. In that part test in which you had electrodynamics, whatever topics are specified will be a part of the first part test. Is this point clear?
Yes, sir.
Can I rub the board?
Yes, sir.
Now we want to know the magnetic field even outside. That means you want to know the magnetic field outside the capacitor plate. So this is your ampere and circulation. Your ampere and circulation will be R, which is greater than A. Now here, closed integral B dot dl will be mu naught. Is there any current passing through the capacitor plates?
No,
Is
sir.
there any current passing
No,
through
sir.
the
No,
capacitor
sir.
plate?
No,
So it will be epsilon naught d phi by dt. This will be mu naught epsilon naught. What area of this ampere and circulation is intercepted by the electric field? Only this area. Pi a square into dE by dt. Do you agree with that? What
yes,
area of this ampere and circulation is intercepted by the electric field? You are not considering fringing fields. Will be very less. B into 2 pi r is equal to mu naught epsilon naught pi a square dE by dt. At the end of the class today, you will be very disturbed. Much of what we have proved till now, we'll prove the reverse of it in 10-15 minutes. Right? So keep your hands on your heart and then listen. This will be, pi will get cancelled. B is mu naught epsilon naught a square by 2r into dE by dt. This is the magnetic field outside the parallel plate capacitors, but in between the two plates. At the periphery, at A equal to R, magnetic field is mu naught epsilon naught A by 2 dE by dt. Mu naught epsilon naught A by 2 dE by dt. Previous derivation, maybe you can put A equal to R. The previous derivation, you found out the magnetic field inside the capacitor plates. Either in that or in this, put A equal to R, you will get B. Tell me when you're done with it.
Done,
One
sir.
1 minute. 1 minute. Yes, sir.
Now it's here there is a jump in this subtopic. The next slot is missing in the syllabus. That's the reason why there is discontinuity in this. All of a sudden they'll jump over to speed of an electromagnetic wave. Mechanism of how the electromagnetic wave is produced will be taught to you in your engineering first year. A time varying electric field produces a magnetic field, time varying magnetic field produces an electric field, and the process continues. Electric field, magnetic field. Time varying magnetic field produces an electric field. Time varying electric field produces a magnetic field. And the process continues. The electromagnetic wave will travel in this direction. Now this mechanism is missing in your syllabus. But then derivation for the speed of the electromagnetic wave, no two textbooks gave you the same. HCV gave you the most orthodox derivation. Mathematically taking a sine function and then doing the integration. He did it the most orthodox way. This is an electromagnetic wave. This is the electric field. The magnetic wave will be in this direction. This is the magnetic. So you will show an electric field in this direction. It is increasing electric field or a time varying electric field because it is a sine function. Time varying electric field produces a magnetic field which will be this. So the electromagnetic wave will be traveling to the right. This is the standard diagram for an electromagnetic wave. Now HCV did the most orthodox derivation, assuming a small element, integrating, finding out the change in flux, Faraday's law, Ampere's law apply karte hue he went ahead. Now how can you simplify this integration and this job? Halliday-Resnick gave a different way of doing it. Simplest among all the authors was given by University Physics. What did they do? They didn't consider a sine function. They considered a planar wavefront. Electromagnetic wave can have any wavefront. Planar wavefront mein advantage is area. You don't need to integrate. You will directly get the answer. Planar wavefront area, you will directly get the answer. You don't need to integrate. So simplest derivation given in University Physics. I'll use that. Because HCV, all of you people have got. Anytime you can refer to. Right? University Physics ka is the simplest derivation. How they did this, I'll explain. First of all, draw this diagram.
Done, sir.
I again repeat, last 15-20 minutes of the class will disturb you to a very great extent. Be mentally prepared. अब तक जो हमने समझा, we will make sure that you feel that this is wrong. And science proceeds that way. We will make you thoroughly convinced that Rutherford's atomic model is complete. And then that next year we'll tell you Rutherford's atomic model is wrong. Bohr's atomic model is right. अब बोर्स एटॉमिक मॉडल पूरा कन्विंस हो जाएंगे, अब तब हम बोलेंगे आपको नहीं यार ये गलत है, क्वांटम मॉडल इज करेक्ट. अब पूरा मेहनत करके क्वांटम मॉडल सीख लेना, then we'll tell you string theory is correct. Same will happen today, right? So ultimately realize one thing in life, change is inevitable. The more quicker you get accustomed to change, better for you. So what is permanent? Change is permanent. Now listen to this. This derivation as it is picked up from University Physics. They considered a planar wavefront. They considered a planar wavefront. This is an electric field, magnetic field, electromagnetic wave. Sine curve लेकर derivation करना है ना यार, वो HCV किया हुआ. Planar wavefront का advantage क्या है? Integrate करने की जरूरत है नहीं. Area is length into breadth. So what do you mean by a planar wavefront? This is a planar wavefront. This is a planar wavefront. So the wave is moving this way. You are always considering sine functions per wave. यहाँ planar wavefront ले लिया to make our life a bit simple. And University Physics played something more smart. ध्यान से सुनिए. They assumed an Amperian circulation like this. One part of the Amperian circulation is outside. The wave traveled from here till here. C delta t. Speed of the wave is c. P Q R S. This length is taken as small. The wavefront traveled from here till here, but you kept your ampere and circulation outside the wavefront. Cheating कर रहे हो यार. आपके एम्पेयर एंड सर्कुलेशन वेवफ्रंट का बाहर रहेगा. पहले भी किया ना यार आपने. सोलिनॉइड के लिए आपने लिया है. सोलिनॉइड का मैग्नेटिक फील्ड डेरिवेशन कैसा किया है? You have played it smart even there. If this is the solenoid, this is the ampere and circulation. You kept one part of the ampere and circulation outside. याद आ रहा है कि नहीं?
Yes, sir.
Yes, sir.
Same thing they played here. They kept one part of the ampere and circulation outside. So what is the advantage of that? You will see. First of all, first part of it, we are applying Faraday's law. Your ampere and circulation ka path is defined. Closed integral E dot dl is equal to minus d phi by dt. Keep your eyes open. Whole of the game is between amperes and Faraday's law. Time varying electric field, time varying magnetic field. Time varying electric field produces a magnetic field. Time varying magnetic field produces an electric field. So whole of the game is played with amperes and Faraday's law. Which law is this?
Faraday's law.
Faraday's law.
Integral E dot dl P to Q plus integral E dot dl Q to R plus integral E dot dl R to S plus integral E dot dl S to P is equal to minus of d phi by dt. Minus d phi by dt लिख सकता हूं मैं. Have a look at it. This flux is magnetic flux. Time varying magnetic flux produces an electric field. This flux is
Magnetic flux.
Magnetic flux.
magnetic flux here is perpendicular to the board outwards. ये है magnetic field. It is perpendicular to the board outwards. So how much change in magnetic flux happens? B into this area. C delta T into L. Are you able to visualize this? Change in magnetic flux will be B C delta T is the length into breadth is L divided by delta. Are you okay with that?
Yes, sir.
d phi by dt. कुछ तो बोलो.
Sir, हमने
Yes, sir.
बाहर वाले
Yes,
से
sir.
consider किया. Why didn't we take the बाहर वाला area like after the
हाँ,
second surface?
अरे भाई साहब, wavefront came from here till here. बाहर वाला area क्यों लूंगा?
Okay, so
I am taking the ampere and circulation to only this area लूंगा.
the changes happen
मेरा
in that
ampere and
area only.
circulation जहाँ पर लिया है वहीं पर change in flux consider करूंगा, बाहर थोड़ी लूंगा.
Okay, sir. Okay, sir.
Now listen. P to Q. How much is E dot dl? E is upwards. Dl is this way. Don't you think this will be 0?
Yes, sir.
They're perpendicular.
Yes, sir.
Q to R will be 0. Q.
No electric field.
You have this outside the electromagnetic wave. R to S will again be 0. Q.
Perpendicular.
Perpendicular.
So S to P is a minus EL. S to P, देख लो, electric field is upwards, L is downwards. Angle between them will be minus EL. Delta T will go. L and L will go. E equal to CB. This is the general equation of an electromagnetic wave. E equal to CB. Now some textbooks will give you E naught is equal to CB naught, where they give E is equal to E naught sine of kx minus omega t, kx minus omega t. अरे भाई साहब, अगर E is equal to CB, this is instantaneous electric field, this is instantaneous magnetic field. So at every instant this relation will be true. Even for peak values it will be true. Even for peak values, it will be true. Yes or no, if you are taking the sine functions. So this is a general expression which will never harm you. So nothing wrong in what university physics did. Same derivation, look at what HCV did. He did it the most correct way. I don't say HCV is wrong. Most traditional way. When we learned it that way only. But university physics played it smart by considering a rectangular wavefront. कहानी अभी बाकी है, ध्यान से सुनो. Anshul, I'll remove you from the meeting here. I told you for once last, I'm telling you what is the syllabus for the part test. आपको ये नहीं सुनना है. Syllabus for the part test itself is the most important thing for you. Then you don't attend this lecture, I'll remove. You are typing these messages only to disturb me. पार्ट टेस्ट ही इंपॉर्टेंट है तो मैं क्यों पढ़ा रहा हूं, मैं छोड़ दूंगा ये. मैं यहाँ पूरा इमर्स होके इसमें कुछ फैराडेस लॉ बता रहा हूँ, आप पार्ट टेस्ट पर 1 and 3 स्वैप्ड सर. हद हो गई यार. अब इरिटेट ही करना है इसे, यही काम है हमें. जबकि बोला हुआ है मैंने that you will not address this. For once I am doing it for the last time. पार्ट टेस्ट गया भाड़ में, लिखो मत लिखो, I damn don't care. To hell with your part test. Am I crystal clear now? I don't know anything about your syllabus of the part test. Is it clear to you? हद करते हो यार तुम लोग. इतना इंपॉर्टेंट सा चीज पढ़ा रहा हूँ, अब आपको पार्ट टेस्ट में क्या है पार्ट, जबकि 3 बार बोल चुका हूँ. गधापंथी का भी हद हो. तो क्या पढ़ा रहा हूँ भूल गया. No. Now have a look. What did you apply here? What did you apply here?
Faraday's law.
Faraday's law. Ampere's law बाकी है. Ampere's law apply करने के लिए have a look at it. इसके नीचे you will take this PQ. इसके नीचे QR, QR, P, yes, I am going in the same anti-clockwise direction, and now integral B dot dl is mu naught. What should I write here? Epsilon naught d phi by dt. Here magnetic field is because of varying electric field, not current. Magnetic field is because of varying electric field, not current. Right? B dot dl is mu naught epsilon naught. Integral B dot dl P to Q plus integral B dot dl Q to R plus integral B dot dl R to S plus integral B dot dl S to P is mu naught epsilon naught d phi by dt. Right? Now, P to Q, B and DL are perpendicular. Do you agree with that?
Yes, sir.
Q to R, B dot DL will be 0 because B.
नहीं चल रहा है.
इसका वाईफाई नहीं चल रहा है, मम्मी क्या करेगी यार, हाथ में जोड़िए. मम्मी से झगड़ा नहीं करने का, मार खाओगे. वाईफाई नहीं चल रहा है तो मम्मी थोड़ी ऊपर से ले आएगी. Listen, B dot DL S to P. Have a look. This will be BL. Right? R to S will be 0. S to P will be BL. So BL is mu naught epsilon naught d phi by dt. D phi by dt in this particular case, have a look. Here, which d phi by dt? Varying electric field or varying magnetic field?
Electric field.
Electric field is in which direction? This direction. Electric field into this area. So this will be mu naught epsilon naught electric field into C delta T. This area into L divided by delta T. delta T, L will go. I am left with B is equal to mu naught epsilon naught C into E. This is the equation of electromagnetic wave. This is the subsidiary equation of electromagnetic wave. थोड़ा ध्यान से देखिए. This electric field, if I substitute here, am I getting the value of C? What is the value of C that you are getting? Have a look. B is equal to mu naught epsilon naught C into electric field is CB. B and B will cancel. C is 1 by root over of mu naught epsilon naught. Isn't this the speed of the electromagnetic wave which we have been using for long?
Yes, sir.
The derivation comes from here. But again, I repeat, this is the shortest derivation, source university physics. The most traditional derivation of integrating, taking a sine function is given in HCV. Because you have HCV, I opted for the shortest version from university physics. Make a note of it. The next 10 minutes of the class is very important. Have patience and learn. That's what changes the dynamics of physics for you. Now, this is physics for the sake of physics, not the entrance point of view. The entrance point of view, they're just giving general equations, JEE Mains mein. They're giving equation of electric field, equation of magnetic field.
Sir, so can you once again explain why Q2R is 0, B dot dl?
Q2R. The electromagnetic wave did not come till there. You have taken an Ampere circulation such that that part is outside the electromagnetic wave. Electromagnetic wave yahi tak aaya.
Okay,
So
okay.
here also magnetic field is 0. Here also electric field is 0.
Yeah,
Just like you have done in solenoid. You kept one line of the Ampere circulation outside.
Done, sir.
1 minute, sir.
Wait, sir.
Done, sir.
Done, sir.
Yes, sir. Done.
Now they defined something very important. This is called Ponting vector. Ponting vector. Firstly, here you will pronounce this as Ponting, though you will spell it as Ponting. Don't pronounce it as Ponting. Ponting. Second, he's from England, not from Australia. You know why I told you this?
Ricky Ponting.
Ricky Ponting.
Ricky Ponting.
He doesn't play cricket, he's a scientist.
Sir, Ponting is PON, not POY.
People like you will be there, that's why I told you we'll spell it as POY. Okay.
So I know.
एक मिनट रुको, मैंने markers cap fell down, right? Now, what is Ponting vector defined as? This is the energy defined per unit area, per unit time, perpendicular to that area. Perpendicular energy flowing per unit area, per unit time, perpendicular to the area is defined as Ponting vector. Energy है ना यार, vector क्यों बोल रहे हो? Perpendicular to the area, hence it is Ponting vector. Energy is a scalar. Quantity of energy flowing perpendicular to the vector is defined as Ponting vector. You will not pronounce it as pointing, though you spell it as POYN, you will pronounce it as Ponting. Right? Now, for which we have to calculate the energy density. Energy density. क्या बोल रहे थे आप? Electromagnetic wave is carrying both electric field and magnetic field. यही तो बोल रहे थे आप? So electromagnetic wave में energy density कितना होता है? Electric field का भी होता है half epsilon naught E square plus magnetic field का भी होता है B square by 2 mu naught. Do you agree with this?
Yes, sir.
Right? Now, electric field and magnetic field energies are being added up. This will be half epsilon naught E square plus B will be E by C whole square by 2 mu naught. ये कहाँ से मिला यार आपको?
Faraday's law.
है
Sir, E is equal to CV.
E equal to CB. E equal
So
to
that was derived from
CB.
Faraday's law only, right?
Right, okay, that's what you meant. I'm okay with it. Fine. So basically, electromagnetic wave B is equal to E by C. Now this will be half epsilon naught E square plus E square by 2 mu naught. Denominator में C square is mu naught epsilon naught. Denominator में C square is mu naught epsilon naught. This is half epsilon naught E square plus half epsilon naught E square. Total energy density is epsilon naught E square. Energy density. Now listen, you converted magnetic field into electric field. If you would have converted electric field into magnetic field, you will get again both of them to be the same. B square by 2 mu naught. मतलब in an electromagnetic wave, जितना इलेक्ट्रिक फील्ड का एनर्जी है उतना ही मैग्नेटिक फील्ड का भी एनर्जी होगा. एक में ज्यादा एक में कम नहीं होता है. electric and magnetic fields carry equal amount of energy. Is that clear?
So can you please just say it again?
These both will be equal. Electric field and magnetic field. Electric field जितना energy carry कर रहा है, magnetic field भी उतना ही energy carry करेगा, electromagnetic wave. Instead of converting into electric field, if you would have converted electric field into magnetic field, you would have got here b square by 2 mu naught and b square by 2. Is it clear?
Yes, sir.
Yes,
Thank
sir.
you.
Now, what is your Ponting vector? You told me total energy epsilon naught E square is what you are telling me, energy density, volume, per unit area, per unit time. This is what you told me is your Ponting vector. This will be epsilon naught E square. Volume is area of cross section into delta T. Area of cross section into C delta T. Area of cross section into C delta T. Right? This will be A delta T. A delta T will get cancelled out. Epsilon naught E square, right? Into C. This is written as epsilon naught E into EC. What have you done? E square you have written as E into E. So Ponting vector's magnitude is epsilon naught E. E is equal to CB into C. E equal to CB, right? So this will become epsilon naught E B C square. C square is mu naught epsilon naught. This will go EB by mu naught is the value of Ponting vector. And in vector notation, it will be E cross B by mu naught. E cross B by mu naught. Vector notation, you can cross verify. It will be E cross B by mu naught. ऐसा कैसा बोल रहे हो आप? This was electric field. This was magnetic field. This was C. Electromagnetic energy is traveling in this direction. That will be E cross B. Right? That will be E cross B. Some textbooks, including Haldor-Resnick, will define Ponting vector as E naught cross B naught by 2 mu naught. Don't get frightened. Both of them are equally right. Both of them are equally right. Ponting vector, both are equally right. ऐसा कैसा हो सकता है? What is E instantaneous value? How will you represent E? E naught sin omega t? Say something.
Yes, sir.
Yes, sir. Yes.
Yes,
B is also written as B naught sin omega t.
Yes, sir.
So E naught and B naught अगर ले लिया sin square function over one time period कितना?
Half.
1 by root 2.
1 by 2.
1 by 2.
1 by
Sin
2.
square over one complete time period is 1 by 2. So अगर instantaneous values दिया तो Ponting vector is E cross B by mu naught. Don't get confused. Some authors will go with this, some will go with this. Both are right. These are instantaneous values. These are peak values. Instantaneous values, peak values. Make a proper note of it. Now comes the biggest heart attack for you. Take it down till here.
So the Ponting vector is perpendicular to the area through which the wave is traveling.
Ponting. फिर से बोलो.
Sir,
Ponting.
Ponting.
हाँ. अब बोलो.
Ponting vector is perpendicular to the area through which the wave is traveling, right?
Perfect. So
Okay.
this is E cross B. This is the planar wavefront which you have taken. This is the planar wavefront that you have taken. This length is C delta T. This is A. That's why volume is A into C delta T. Sorry. Denominator में क्या लिखा है मैंने? Volume Denominator में why did I take only A? Yeah, that's per unit volume. This is A into C delta. This is per unit area per unit time. Somebody is asking, how did they verify the speed of light experimentally? You must have heard of Michelson-Morley experiment. सुना है?
So वो strike करके फिर वापस आता है क्या?
हाँ.
Actually the time.
Michelson-Morley's experiment determines the speed of light. But I think now it is not there in your syllabus. Michelson-Morley experiment कभी पढ़ाया गया था आपको? Relativity के starting में पढ़ाएंगे. No, you don't have it. मगर HCV में है in the chapter relativity. Experimentally, speed of light is verified. Don't be under the impression that it is theoretically calculated. But the experiment is called Michelson-Morley's experiment.
So relativity of HCV is not in our syllabus, right?
Relativity is not there in your syllabus. Now, do you have Halliday-Resnick crane with you people?
Yes,
Yes,
sir.
sir.
Okay. You will have to turn to page number 874. Volume 2. Where's up? 874. Rather 870, 881. Page 881. Page 881. खोला है कि नहीं आपने?
Yes, sir.
Page 881, volume 2, Halliday-Resnick crane. Question number 12. Question पढ़ोगे आप लोग. Question number 12. See this diagram. This diagram. Question number 12. Please read the question. If you understood the question, you will get disturbed. Pic भेजो please. मैं अभी pic भेजने के लिए I'll have to disconnect from my cell phone. Somebody please take a pic and post it in the group. Question number 12. वो पूरा पेज का पोस्ट करो 881 because question number 14 भी करना है. 881 वॉल्यूम 2 पिक पोस्ट करो, मतलब आपके पास हाइड्रोरेस्निक रिंग नहीं है, मतलब
Sir,
दोनों सब
Walker है.
झूठ बोल रहे हो, ऐसा कैसा मान लो?
Sir, seriously Walker है.
Question number 12. If you understand the question, you will be disturbed. That is the beauty in the question. पढ़ो जल्दी पढ़ो. I will discuss that. Sir, no one is sending on the group. Your classmates, you know them better than me.
So
Hey,
sent it.
somebody send in the group, no yaar.
Oh, sir, I sent it.
Okay, it has come. It has. क्वेश्चन तो पढ़ो. अंग्रेजी पढ़ना आता है कि नहीं आपको?
Right, sir.
क्वेश्चन पढ़ा है?
Yes. 1
ये
minus.
वही
डिस्टर्बिंग लगता है, राइट?
हाँ sir, बहुत निश्चित.
That means you are in right track. वो ये बोलना चाहता है कि अगर करंट इस डायरेक्शन में फ्लो कर रहा है तो electromagnetic energy is entering into the wire from the surrounding perpendicular to that. ये चार्जर का वायर है, ये चार्जर का वायर है, राइट? अगर इसके अंदर करंट फ्लो कर रहा है तो इलेक्ट्रोमैग्नेटिक एनर्जी इज एंटरिंग द वायर फ्रॉम द सराउंडिंग. ये बोलना चाहते हो? यही तो बोल रहा है. एंड ही इज हालिडे-रेसनिक. हालांकि ये क्वेश्चन हालिडे-रेसनिक का ओरिजिनल नहीं है, ग्रिफिथ से उठाया गया है, राइट? ग्रिफिथ्स का थ्योरी, ही पुट इट एज अ क्वेश्चन. Standard electromagnetic theory says energy inside a wire doesn't pass through the wire, it is entering from the surrounding. Right? It should be true because electromagnetic field is storing energy. So एक current करता क्या है हमारे बीच में? Current is a myth. Current जैसा चीज कुछ है ही नहीं. It is electromagnetic field and waves. Current आपने आपकी convenience के लिए define कर दिया. Rate of flow of charge. You have defined current to your convenience, flow of charge. एक fundamental quantity बना दिया. Cheating आपने current define करते वक्त किया है भाई साहब, अभी नहीं. अब इसका जरूरत कहां पड़ेगी आपको? प्रूव तो करके दिखाओ. क्वेश्चन तो पढ़वा लिया आपने, अब प्रूव करो. Can I rub the board?
Yes. Yes sir.
Yes, sir.
This is a cylindrical wire as given by them. This is a cylindrical wire. Am I right? Your Pointing vector is this way. perpendicular to the surface. Pointing vector is perpendicular to the curved surface. Right? Radius is R, current is I. Heat generated in the wire कितना होगा अगर current is I?
I square R.
I square R.
और अभी अभी क्या बोल रहे थे आप? करंट जैसा कुछ चीज है ही नहीं, इलेक्ट्रोमैग्नेटिक एनर्जी इज एवरीथिंग, यही तो बोल रहे थे आप.
Yes, sir.
Yes, sir.
तो इलेक्ट्रोमैग्नेटिक एनर्जी आपको आई स्क्वायर आर हीट देगा कि नहीं, प्रूव करो.
Yes,
मुझे
sir.
तो एक्सपेरिमेंटली पता है, मुझे तो एक्सपेरिमेंटली पता है कि हीट जनरेटेड इज आई स्क्वायर आर टी. अभी तुम बोल रहे हो करंट जैसा कुछ चीज है ही नहीं, इलेक्ट्रोमैग्नेटिक एनर्जी इज एवरीथिंग. तो इलेक्ट्रोमैग्नेटिक एनर्जी सराउंडिंग से अंदर जा रहा है, अगर मैं मान लूं, प्रूव इट दैट इट इज आई स्क्वायर आर, देन आई विल बिलीव इट. दैट इज द क्वेश्चन अबाउट. फर्स्ट ऑफ ऑल डायरेक्शन देख लो, डायरेक्शन देख लो. एक सिलेंड्रिकल वायर ले लेते, दिस इज द सिलेंड्रिकल वायर, this is the cylindrical wire. Current is flowing this way, means electric field is in which direction? Same direction.
Yes.
Electric field is in this direction, magnetic field is like this. Yes or no?
Yes, sir.
तो एक point on the surface यहाँ पर लेकर डायरेक्शन देख लेते. Electric field is this way, magnetic field is towards you. E cross B perpendicular to the surface inwards आ रहा है कि नहीं?
Yes, sir.
Yes.
एक और पॉइंट ले लेते, यहाँ पर electric field is in this direction because of current, magnetic field is downwards. Agreed? Yes or no?
Yes, sir.
Yes.
E cross B, E cross B perpendicular to the surface inwards आ रहा है. E
Yes.
cross B, every point E cross B will be perpendicular to the curved surface area inwards. आप ये बोलना चाहते हो कि electromagnetic energy is entering the wire from the surrounding perpendicular to the surface inwards. Maxwell's theory तो वही तो बोल रहा है. अब Poynting vector magnitude U divided by A into delta T. This is what is your Poynting vector? U. This is equal to EB by mu naught. This is what you derive, right? U is E B A delta T divided by mu naught. I got A delta T to the numerator on the right hand side, or keep delta T to the denominator, I don't mind. U by delta T will be power. एक सेकंड रुको यार, कोई कॉल कर रहा है. Are you people able to hear me?
Yes, sir.
Yes.
Yes, sir.
Now listen. Now what did you take? Poynting vector is energy per unit area per unit time. This is EB by mu naught. Right? Energy, I kept delta T down. Energy per unit time. EB, I got area. This area is the curved surface area. If I take this length to be L, this will be E. B. By the way, how much is B? Mu naught I by 2 pi R. Magnetic field just on the surface of the wire, infinite long wire. 2 pi RL divided by mu naught. Great. मैग्नेटिक फील्ड सही सब्स्टिट्यूट किया है मैंने.
Yes, sir.
अब इलेक्ट्रिक फील्ड सब्स्टिट्यूट कर रहा हूं. V by L सही किया है मैंने.
Yes, sir.
Yes.
V by L. अब V को सब्स्टिट्यूट कर रहा हूं. I into resistance R. Now here small r is the radius. Resistance is capital R. Potential difference across this will be I into R. Agreed?
Yes, sir.
अब देख लो 2 pi r कैंसिल हो रहा है. L कैंसिल हो रहा है. म्यू नॉट कैंसिल हो रहा है. I स्क्वायर r आ गया. एनर्जी पर यूनिट टाइम. पॉइंटिंग वेक्टर से आपको कितना एनर्जी वायर के अंदर जा रहा है?
I square R.
And you know that is the heat generated by the wire.
Yes, sir.
Now you understood where from this energy is coming. कहां से आ रहा है?
Electromagnetic wave.
Electromagnetic.
This is electromagnetic theory. क्या कर रहे हो यार? पूरा 6 महीने करंट 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 बोल के दिमाग का दही बना दिया. अब बोल रहे हो करंट जैसा कुछ चीज है ही नहीं, सब कुछ इलेक्ट्रोमैग्नेटिक एनर्जी है. दिस इज लाइफ. दिस इज एग्जैक्टली लाइफ.
So even Ohm's law is not defined right then.
Everything is defined. Don't tell me it's not defined. Everything is defined. When we tell you Bohr's atomic model, we don't tell you Rutherford's model is completely wrong. It is partly correct. Some corrections. ऐसा corrections करते जाएंगे. That's why I tell you, the more you understand physics, the more helpless you feel before the creator's universe. जिसने भी universe बनाया, इतना intriguing है कि that you feel really helpless. We are actually speck in this universe. We are just a small speck. It's a mystery and the only magic in this universe. Homework, question number 14, Halliday-Resnick train on page 881. Page 881. याद करो, मैंने एक बार बताया था आपको, कैपेसिटर्स में when you are charging a capacitor, half the energy should be lost in the form of heat. यही तो बोले थे आपने. प्रूव भी किया करंट इलेक्ट्रिसिटी में. Yes or no?
Yes, sir.
If there is no resistance, I asked you then, what will happen? Then we said that amount of energy will be lost in the form of electromagnetic waves. उस क्वेश्चन का सवाल इस क्वेश्चन में छिपा हुआ है. उस क्वेश्चन का सवाल इस क्वेश्चन में छिपा हुआ है. ये ढंग से सॉल्व करो, वरना मैं I take a pic by evening, solve and give me your feedback in the group. I want to know, could you solve it or not? If not, I have the solution right in front of me in my notes. Right? This is the question. I'll send you a pic of it, but I want you to attempt. I don't want to make life that simple for you.
So could you repeat that what you said? Capacitor one you were saying, no?
नील कल थाने आ रहा हूँ
हाँ सर.
बस समझ में कैपेसिटर के बारे में मैंने कुछ नहीं बोला है वो क्वेश्चन पढ़ो क्वेश्चन नंबर 14 आपको
हाँ
खुद
सर,
समझ में आ जाएगा
Okay sir.
राइट क्वेश्चन नंबर 14
Yes sir, got it. Thank you.
now listen अब somewhere down the lane even we are human beings we are biased आपको आईआईटी में घुसने के लिए दिस नॉलेज इज नॉट नेसेसरी अभी वो 14th क्वेश्चन जो बोला है उसकी भी नॉलेज इज नॉट नेसेसरी आप एनसीईआरटी देख लो पॉइंटिंग वेक्टर तक डिराइव नहीं किया उसने तो क्या क्वेश्चंस पूछ रहे हैं यार वो लोग वो इलेक्ट्रिक एंड मैग्नेटिक फील्ड का जनरल इक्वेशंस दे रहा है राइट 2019 एंड 2020 का मैं क्वेश्चंस विद आंसर्स टाइप करवा के आपको 2 दिन में भेजूं एक बार देख लीजिए दूसरी बात एनसीईआरटी में लास्ट पेज में इलेक्ट्रोमैग्नेटिक वेव का स्पेक्ट्रम दिया हुआ है एक्सरेज का वेवलेंथ ना अब सुनिए मैंने इलेक्ट्रोमैग्नेटिक वेव्स पढ़ाया आपने भी पढ़ लिया आपने भी बहुत अच्छा कॉन्सेप्ट सीखा है नाउ यू आर हैविंग ए ग्रेटर विजन बट इस पर जो क्वेश्चन आ रहे हैं जेईई मेंस में व्हाट इज द वेवलेंथ रेंज ऑफ एक्स-रेज wavelength range of X-rays. You understood what is the problem with this chapter?
Yes, sir.
The questions asked are not concept based, they are memory based. So NCERT का जो इस chapter में last page में दिया हुआ है medical applications of X-rays, medical applications of infrared rays, applications of different spectrum of electromagnetic waves, पूरा 1.5 page दिया हुआ है, please पढ़ना है. आई बात समझ में?
Yes sir.
Monday evening, I'll keep the doubt lecture. We will have 1 or 2 doubt lectures. Nowhere, nothing to worry about. Whole of the week, whenever you people are, you have accumulated some doubts, leave a message in the group. That day evening, I'll keep the doubt lecture. Is that clear? Somebody want to take? Somebody is taking 3 block systems. 3 block systems एक काम करोगे? नहीं ले लूंगा मैं आपके क्लास में ही ले लूंगा. Don't worry.
So 3
Though
blocks.
I have uploaded that on the YouTube. Junior batch में लिया है, I have uploaded, but no, don't worry, I'll take it in a class. Hey, Nikhilesh, page 881 is this. अभी जो क्वेश्चन this capacitors के बारे में बोल रहा हूँ मैं. Somebody take a pic of this page and post it in the group.
Sir, sent it.
This time. Right? This completes EM waves, but at the same time, I'm telling you, जो JEE mains में 2019 and 20 में questions on EM waves आए हुए, they were not based on the concept. Information for the sake of information, वो मैं type करवा के आपको भेजूँ. For you to collect those online question papers will be difficult. I have collected, right? इसमें से type करवाना है, करवा के दूंगा. Fine. 3 block system आज नहीं पढ़ाऊंगा. It will not go that easy. So see you people on Monday evening. Finish
So-
your homework at the earliest.
So I wanted to ask something. Sir, now I've finished studying mechanics for part test. Now you're changing the portion. तो क्या
Portion का change is done for your convenience because EMI AC बहुत सारे लोगों का pending है. You have 1 more week. When is the part test?
Sir, next week now I've
Saturday,
organic left
Sunday.
and maths भी आधा बचा है sir. Mechanics कर दिया just कल ही खत्म किया.
Maths chemistry के बारे में मुझे कुछ पता नहीं. That syllabus may be the same. I don't have any idea. Physics के लिए I have told them please give some time so that kids finish EMI and AC. Then they said, sir, we don't have time because board exams have already been declared. February 15th, say your practicals will start off. So where do we have time is their point. So then the only other alternative is crash course ka first part test will be EMI and AC so that you get time to complete EMI and AC in detail. And suppose you have done something that is an advantage for you either way, you can conserve that time by default.
But sir, I don't have time for magnetism, EMI, AC.
Abhi karo, this week you must do. This week you must do.
Because
EMI
sir, I've
and
done it
AC.
before. EMI and magnetism I've done before. AC is only left, and
Khatam karo. EMI AC is important as far as the JE paper pattern is concerned. Hence that emphasis, so that people get time to complete it.
Sir, one more doubt, sir. Sir, J main date has not been announced yet, so it will be.
Has not yet been announced, so there is a confusion there as well. They generally will take all the board exams into consideration. So that will not clash with your board exams. It will be after your board exams only. If not, your board exams dates will have to be changed. And that the government will take care of. Don't worry about it.
Okay, sir. Thank you so much.
So, will the exam will be after April or before, like in March, the first JEE mains exam?
Probably March ending or April first week.
Okay, sir. Thank you.
Is my guess. Remember, is my guess.
Yes, sir. Yes.
Yeah, but till April first week there are boards, no sir? How it can go?
March first week.
Are but till April 4th there are boards, no?
Then it will be after April 4th. But remember, if ever there is a clash, board ka schedule will change, not the JEEs.
Because sir, last year they had changed the schedule of JEE mains because of board.
This time it will be reversed. Generally, boards take care of JEE mains examination dates.
So just wanted to ask that for revision of previous chapters of electrodynamics is solving the DC Pandey, the selected problem book which you had sent PDF, that will be good.
That will be good, but do that after you have solved that module which I have sent you people. Crash course ka ATM module I sent you people. Soft copy, module 1, module 2.
Sir, the final lap one?
Final lap, jo bhi hai. Right?
Okay, sir.
इसमें summary is given in front of every chapter. Quick revision के लिए class notes, module, then those 500 problems in the third stage, depending on the time available.
Okay, sir.
Sir, if possible, can we leave ATM and just do the Cengage or DC Pandey normal book problems?
नहीं.
Okay, sir.
Cengage DC Pandey previously you have done or not for major tests?
So for mechanics and some capacitor and electricity I had done, but for magnetism and EM.
You can try, but I would suggest if booklet is done, first solve ATM.
Okay, sir. Okay.
Rather final lab.
And sir, also one more doubt. इस साल sir JEE means 4 attempt का possibility है कि फिर 2 ही होगा, like?
शायद 2 होगा, शायद.
Okay, sir.
Sir, I had a small doubt in the concept which is taught behind. So the energy equation which we write before, we always included, we did not consider the work done by this Poynting vector also.
But we were taking that to be I square R without our knowledge. We were assuming it is because of current. Now you are telling me there's nothing called current. Then where from this heat came? From the electromagnetic wave.
The heat is not released by resistor, heat is released by the electromagnetic wave.
Electromagnetic energy enters, raises the temperature of this. Once its temperature rises, Stephen's law tells me that this amount of heat is dissipated.
Okay, sir.
So, sir, the wire does not produce heat at all.
Wire produces? जब electromagnetic energy enters the wire, wire का temperature बढ़ेगा ना यार, ms delta T का.
मतलब before that, by itself, it doesn't produce heat.
Nothing produces. Somebody is having Pathfinder. Pathfinder is not for JER. Pathfinder will waste too much of a time for you. If you are done with every material, you can try few problems from Pathfinder because they will be killing a lot of time.
Sir, you have some old test papers which you can share with us so we can do in time limit.
It is, I don't have that way of a test paper here.
Okay, sir.
I get it mailed from Andheri office only. I'll be there today evening. I'll get it mailed. I'll get them mailed to myself so that I can send it to you. Let me see.
Okay. Thank you so much, sir.
So in the childhood we were taught that the heat loss and resistance due to that collision and all that theory. So it's wrong.
According to Maxwell's electromagnetic theory. कि ऐसा क्यों बोल रहे हो यार? कल को मैक्सवेल्स थ्योरी को भी रॉन्ग प्रूव करेंगे इंजीनियरिंग फर्स्ट ईयर में, तब याद करना.
Okay.